All right, I want to make a real quick video and just review some of the easy ways to graph the different types of graphs we've done so far. So this first one, I'm graphing the line y equals 2/3 x minus 3. And keep in mind, every time you graph a function, you want to think about what do I expect this to look like. So I expect this to look like a line with a positive slope. Remember, this is the y-intercept. So I'm going to count by ones, and you should really scale your graph. So the y-intercept is 0, -3, so I will plot that point. Then my slope is 2/3, so it's a positive, so I'm going to go up 2, because you always do the rise over run, and to the right 3, so that's going to show a positive slope. I'm going to do it again, up 2 and over 3. Remember, you could also go down 2 and to the left 3, and then we have our, let's see if I can do this here. And then we get our line. Okay, and then I asked you to state the x and y intercepts as ordered pairs. Well, one of them we knew for sure. So we know that the y-intercept is 0, -3. To find the x-intercept, I can look at it and say, well, I think it's 4.5, but I don't really know for sure. So remember, to find the x-intercept, we let y equal 0, and we solve for x. So I'm going to add 3, and then I'm going to multiply by 3/2, because that's going to cancel the 3's and the 2's. So I get x equals 9/2, which sure enough is 4.5. So then my x-intercept is, and you could say 9/2, 9/2, 0. But I do want you to get in the habit of doing that as an ordered pair. All right, so I think we've satisfied that one. On this next one, also when I look at this, I think, okay, this is a linear equation, but it's in standard form. So I don't graph it the same way. Now you could, if you wanted to solve this for y and put it in slope-intercept form, you could do that. You would get -3y equals -2x plus 8. You would divide everything by -3, so you'd end up with a positive 2/3 x and a minus 8/3, and then this is what you would plot. I don't do it that way. What I do is I think, well, what if I let x equal 0? So then that part is gone. And then when you solve, I'm putting my hand over that, but that doesn't do any good, does it? And so if you let x equal 0 and solve for y, you're going to get y equals -8/3. So then that means it's 0, -8/3. And then let y equals 0, and when you do that, you get x equals 4. So then that's the point 4, 0. So when I graph this one, I'm still going to scale my graph by ones. I would plot the point 4, 0, and I would plot the point 0. -8/3 would be -2 and 2/3. And then I could draw the line. Okay, and x and y intercepts we've already found and listed those. So I think that's all I had asked. Yep. Okay, so again, how I graph the line depends on how the line is given to me, or the equation. If you prefer to do slope-intercept form, remember you can. All right, so here we are graphing an absolute value equation. So what do you have to remember? The negative makes it open down. The 2 is going to act kind of like the slope. It's going to be steeper. This moves it 1 to the right, opposite the direction of the sign, and this moves it up 3. Okay, so we're going to label the vertex. So the vertex, remember the parent graph would have been 0, 0. If we go to the right one and up 3, here's the vertex. So that's the point 1, 3. Okay, so you find that here in the equation. Then I know it's going to open down, and it has a slope or a steepness of 2. So I'm going to go down 2 and over 1, both directions, to make a V shape. From that point, go down 2 again and over 1. You can do it again. Down 2 over 1. So you build this V-shaped graph, and then we're going to have both parts of that. So there's my graph. Okay? So again, using all the clues from the function, knowing that an absolute value graph is going to look like a V, the domain and range. To get the domain, notice the arrow goes to the left, the arrow goes to the right, so that means it's all real numbers. If you put it in interval notation, it looks like this. To get the range is not all real numbers, because notice this is the highest point on my graph. That's a y value of 3. All the values are either 3 or below. So we would say y is less than or equal to 3. If you want to put that in interval notation, you would put the negative infinity on the left and the 3 on the right. And it would have a bracket because it includes the 3. Okay? Here's one. Notice this. If there's not anything in front, remember it's like having a 1. So that's like having a slope of 1. This moves to the right 3. And it's not going to move up or down because there's like having a plus 0 there. So when we graph that, we're just going to go from 0, 0. We go to the right 3. And that's the vertex. So the vertex is 3, 0. Slope is 1, so up 1 over 1, both directions. Remember, we need to make this look like a V and not a line. So then we graph this. Okay, domain, again, all real numbers. And the range, okay, notice that it's not all real numbers because we can't go below 0. So we say y is greater than or equal to 0. Okay, on this next one, we're going to graph the inequality y is less than 3x minus 1. Notice there is no absolute value, so I don't have a V shape. This is going to be a line, so this is a linear inequality. So what that means is we have to think about dashed or solid. So because this does not have an equal to part, we know it's going to be dashed. So I graph the line, I graph the boundary line. The y-intercept is -1. So let me plot this or scale my graph. So here's my y-intercept. The slope is 3, so I'm going to go up 3 and over 1. And when I graph this, you want to, if you write down the word dashed ahead of time, then you guys don't have to write, this is supposed to be dashed on your homework. A lot of you did that. And that's okay. So we would graph our line, make sure it's dashed, and then we have to test a point. So you can test 0, 0 because the line doesn't pass through 0, 0. And if you do, plug in a 0 for y and a 0 for x. So we get 0 is less than -1, and that is false. So I'm going to shade the side that doesn't include 0, 0. Kind of hard to shade with a pen like this. So we would shade that side. Now, little shortcut, this only works if you have solved the equation for y. Well, it works otherwise too, but there'd be a chance you might make a mistake. It works well. This is less than, okay? Less than. We want the y values that are less than the line. So go to the y-intercept and think about the values of y that are less than the line. And then that puts you on the correct side. So that's a way to do it that's quick and easy without having to test a point, but testing a point always works. All right, so graphing this one. And I don't know if we did one exactly like this. It's in sort of standard form. So I would use my x and y intercept method to graph this. But I also have a fraction. And you can actually use fraction busters. I'm going to multiply everything by a 2. When I do that, I'm going to get x plus 6y is less than 10. And I'm going to graph this instead. And this is going to give me the same, it will give me the same x and y intercepts, except I don't have to deal with the fractions, even though I guess I do have a fraction over here. But anyway, so my x-intercept, if I let y equal 0, I get x equals 10. So that's the point 10, 0. My y-intercept, if I let x equal 0, I get y is 10 over 6, which is 5/3. So 0, 5/3. So I'm not going to mark 10, 0, so I'm going to count by 2's instead. So then 10, 0 would be here. And 5/3 would be the same as 1 2/3. So that's actually going to be just maybe here. We're just kind of approximating. And dashed. So I'm going to make my line dashed. Okay, not the best of lines, but you kind of get the idea there. And then testing a point. You can actually test a point up here in this one if you don't want to deal with the fraction. So if I test 0, 0, and plug a 0 in, I get 0 is less than 10, and that's true. So then I would be shading this side. Okay? And now a linear, an absolute value inequality. So again, you have to pay attention to dashed or solid. This one's going to be dashed. And because it's absolute value, we know it's going to be a V shape. So I have to find the vertex. That's my locator point. Not the y-intercept for a line is our locator point, but here we want to use the vertex. So it's going to be -1 because we go to the left 1, and -3. So -1, -3. It opens up, has a slope of 2. So up 2 over 1. Both directions. Up 2 over 1. Okay, now we already decided it's dashed, and we know it's a V shape. And because it's an inequality, I have to shade. Now, you can still test a point. If you test 0, 0, you can do that. But it's a lot more work to test a point. So normally when you graph an absolute value graph, it's solved for y. So you take a look at the symbol. It's less than, so we're going to shade below. Below what? We'll use the vertex as your locator point and shade below, and it puts you on the outside. By the way, if you tested 0, 0, it would be false, which is why we would be on the other side. So you can actually use this symbol to decide, do I shade above or below my V-shaped graph? All right, and one more. So I know that this is going to be solid this time. I know my vertex is going to be a +2, because remember it goes the opposite, and a -3. So I'm going to plot 2, -3. This is like having a 1 here, and it's positive, so I'm going to go up 1 over 1. It's like having a slope of 1, both directions to get my V shape. And I've already decided it's solid. And then I have to decide where to shade. So again, I'm going to use that same idea here. So this is going to be above. So I want to shade above the V, which puts me inside. Because now, again, how do you decide above? Go to the vertex and shade above. And then that puts you on the inside. So I didn't do a piecewise on here. We're going to practice that tomorrow. So, but this should help you out. You're going to have some graphing problems that you need to do that are like this, but I just kind of felt like we needed to have, I needed to kind of pull you together on this and just practice and on all the different kinds of graphing that we've done so far this year.